What's up, everyone? Welcome to Print Talk. I'm Neil, and as always, I've got Kenneth here with me. How's it going, Kenneth?
Hey, Neil. I'm doing fantastic. I'm really excited for today's deep dive. You know, we're going to be talking all about Z-banding and Z-wobble.
Yeah, these are problems that I think pretty much every 3D printing enthusiast runs into at some point.
You know, you find we get to the end of that print that you've been working on for so long, and bam, it's got those like weird lines and bumps all over it.
Yeah, you know, it is kind of funny you should mention that, because I was working on a print the other day, and it was this little model spaceship for my nephew, and I was so proud of it. You know, it was coming out so smooth, so detailed. But then as it started getting taller, I noticed these like really faint lines, almost like ridges, running around the fuselage. It was really subtle at first, but then as the print went on, it get more and more obvious.
Oof, I know that feeling. It's like when you get a brand new car and you find a scratch on it. I mean, it's not a deal breaker, but it still kind of like takes away from the whole pristine finish you were hoping for. And you're right, it does often become more noticeable as the print gets taller, which is kind of a bummer, you know, especially if you've been like super carefully watching those first few layers and everything looks perfect.
Right. It's like the printer just decided to play a prank on me.
Yeah.
You know, but hey, that's why we're here today, right? We're going to like uncover the mysteries of what causes this, and more importantly, figure out how to get rid of them for good.
I love the energy. And you're so right. Knowledge is power. So for our listeners who might be newer to 3D printing, can you explain what exactly we mean by Z-banding and Z-wobble? What does it actually look like on the print, and why is it such a pain?
So you're looking at your freshly printed object, and instead of having this nice smooth surface, you see these horizontal lines or bands going all the way across it. It's kind of like the print head took a little detour on each layer, and it leaves this slightly raised or indented line. And depending on the severity, it can be very subtle or very pronounced. And trust me, once you notice it, you can't unsee it.
It's like you can't unring a bell, right? And it's not even just like an aesthetic thing either. I mean, some Z-banding might just be cosmetic, but a lot of times it can actually weaken the print, especially if those lines are super deep, or if you're printing something that has to be functional and withstand stress.
It's like if you're building a tower out of blocks, and some of those blocks are a little bit like misaligned or jutting out, the whole structure is going to be a lot less stable. Is that kind of where Z-wobble comes into play?
Exactly. Z-banding is that visual symptom, and Z-wobble is often the mechanical cause behind it. Think of it like this. The Z-axis is the part of your printer that moves the print head up and down for each layer, and if there's any unwanted movement or instability in the Z-axis, then that is what manifests as those lines on your print.
Okay, so if the Z-axis is moving nice and smooth, then we get those nice clean layers. But if it's wobbling around, then it's going to throw everything off and cause that Z-banding. Starting to make a lot of sense now. But I mean, the Z-axis seems pretty straightforward, right? It's just moving up and down. What could actually go wrong to make it wobble?
Well, even a simple mechanism can still have its quirks, especially when we're talking about the level of precision that 3D printing needs. There are a few main players in the Z-axis that we need to pay attention to. So first, you've got the stepper motor. That's like a muscle behind the whole movement. It rotates the lead screw, which is what actually moves the Z-axis up and down.
Gotcha. So the stepper motor's like the engine, and the lead screw's like the transmission.
Yeah.
What else is there?
Then you've got the rod coupler. It connects the stepper motor to the lead screw, and this little guy is super important. It makes sure that a smooth and stable connection between the motor's power and the lead screw's movement. But if it's loose or not aligned right, you can get all sorts of wobbly nonsense.
So it's like the missing link that connects the power to the action. Okay, it's all making sense now.
Oh.
So if any one of these, the stepper motor, the lead screw, or the rod coupler, isn't working right, then we can end up with Z-wobble, which then shows up as Z-banding our prints.
You got it. You're natural at this 3D printing detective work. But wait, there's another piece of the puzzle we haven't talked about yet, and that's the filament itself, the whole extrusion process.
Oh, right. It's not just about the Z-axis moving correctly. It's also about how the filament is actually being put down layer by layer. And I have a feeling this is where things can get a little bit messy, especially if we're not careful.
You're telling me, think of it like icing a cake. You need a nice, even flow of icing to get those perfect lines. But if the icing is too thick or too thin, or if there are any clumps or air bubbles in it, and it totally show up in the final product.
And I'm guessing that same principle applies to 3D printing. If the filament isn't coming out smoothly, it can create those ridges and inconsistencies, even if the Z-axis is moving perfectly.
Exactly. There are actually a few different things that can affect filament flow and cause Z-banding. One of the most common is a clogged nozzle. Just like if the tip of your icing bag is blocked, a clogged nozzle restricts the filament flow, and then you get uneven extrusion in those bands.
That makes total sense. It's like trying to squeeze toothpaste out of a tube with a tiny hole that's going to come out all weird. Okay, so keeping the nozzle clean is obviously super important. What else can mess with the filament flow?
Another big one is the filament quality. If you're using low-quality filament, it can have an inconsistent diameter or impurities that can clog up the nozzle or make the extruder struggle. And then, again, you get that uneven extrusion and banding.
So it's like using bad yarn when you're knitting. You're not going to get a nice, smooth fabric, no matter how good of a knitter you are.
Haha, that's a great analogy. Using high-quality filament that's designed for your printer and the material you're printing with can make a huge difference in how consistent and how nice your prints turn out.
Okay, so clogged nozzle, low-quality filament. Got it. Anything else that can throw a wrench in the works?
Temperature is huge. If the temperature of the nozzle or the print bed isn't right, then the filament won't melt and cool correctly. And then, you guessed it, more Z-banding. It's kind of like if you're trying to bake a cake and your oven has a busted thermostat, it's just not going to turn out right.
So it's not just about setting the temperature to the right number. It's about making sure it stays consistent the whole time as printing.
Yep, and even small fluctuations can affect things, especially with filaments that are finicky about temperature. So you want to be sure your printer can maintain those stable temperatures. And sometimes you even need to look at your printing environment to make sure there are any outside things affecting the temperature.
Okay, so we've got a lot of potential suspects here. It seems like it takes a bit of detective work to figure out what's causing Z-banding in any given print. Where do we even start?
You're right, it does take a little bit of detective work, but don't worry, we're going to equip you with all the tools and the knowledge to become a Z-banding detective. The key is to look at the patterns of the banding on your print, and then use that to narrow down the possible causes.
Sounds intriguing. Okay, so I've got a print with Z-banding. What should I be looking for to start my investigation?
The first thing you want to do is look closely at how the banding is patterned. Are the lines consistently spaced? Like, do they have a regular pattern, or are they kind of more random?
Okay, so we're checking out the banding like it's fingerprint. What does a consistent, regular pattern tell us?
If the lines are consistent and have that repeating pattern, then it's usually related to Z-wobble. Into that when you're driving over a railroad crossing and you feel those bumps, it's a predictable pattern because of how the railroad ties are spaced.
Oh, got it. So if the bands are spaced out evenly, then I should be focusing on the mechanical parts of the Z-axis, like the stepper motor, the lead screw, and the rod coupler. What if the banding looks more random, like there's no real pattern?
That probably means you're dealing with inconsistent extrusion. It's like when you hit potholes on a bumpy road, they're totally unpredictable and random, just like the bands caused by changes in how the filament is flowing. So in that case, you'll want to look at the nozzle, filament quality, and temperature consistency.
This is super interesting. It's like we're piecing together a puzzle, using the clues we can see in our prints to find the problem. I'm already feeling a lot more confident. So, say we've narrowed down the culprit. What are the next steps? How do we actually go about fixing these Z-banding and Z-wobble issues?
Great question. Now that you've found the most likely suspect, we can talk about some specific solutions for each problem area. And don't worry, we've got a whole bunch of tips and tricks to help you get those perfect prints you've been dreaming of.
Awesome. I am ready to roll my sleeves and get to work.
Should you?
Maybe we should take a quick break first and then come back and dive into the nitty-gritty of actually fixing these problems.
Before the break, we were talking about becoming like Z-banding detectives. Using the patterns in your prints to figure out what's causing those annoying lines. You ready to turn those wobbly prints into some masterpieces?
You bet. I've got my magnifying glass and my detective hat ready to go. Where should we start our journey to printing perfection?
Let's start with those mechanical issues that can cause Z-wobble. Remember our Z-axis elevator analogy? If the motor's all shaky, or the lead screw is bent, or the coupler is loose, those are the things we gotta fix first.
Right. So step one, check the stepper motor, which is like the engine that makes our Z-axis move. What should we be looking for?
Make sure it's actually attached to the printer frame, You'd be surprised how often it's just a loose screw causing all that vibration and wobbling. So if you see the motor moving at all when the printer's going up and down, grab your screwdriver and tighten those screws.
Got it. A loose stepper motor is like a wobbly table leg. Just tighten it up and it makes a big difference. What if the motor itself is the problem? Like what if it's old and jerky? like a sputtering engine.
Yeah, then it might be time for a new one. It's like swapping out that old clunker for a shiny new engine. Your prints are going to love the smooth ride. Luckily, stepper motors are pretty easy to replace, and you can find tons of videos online to walk you through it.
Okay, so we checked the stepper motor, made sure it's running smooth. What's next on the Z-wobble fix-it list?
Now it's time to take a look at the lid screw. That's that long threaded rod that guides the Z-axis movement. Imagine it like the tracks for our elevator. If those tracks are warped, the whole ride's going to be bumpy.
Makes sense. How can we check for bends in the lid screw? Do we need any special tools?
Nah, all you need is a flat surface and a good eye. Take the lead screw out of the printer and try rolling it on a table. If it rolls smoothly and evenly, you're good. But if it wobbles or you feel bumps or resistance, then you've got a bend.
So we're basically checking for flat spots, like you would in a car tire. Any inconsistencies could throw things off. What if we do find a bend? Can we just, bend it back, or do we have to get a new one?
If it's just a small bend, you might be able to carefully straighten it out. But if it's really warped, it's best to replace it. You can get new lead screws online or at a hardware store. It's a pretty cheap fix, and it can make a huge difference in your prints.
Lead screw?
Yeah.
Check. Okay, what's the last thing we need to look at for a wobble-free Z-axis?
The unsung hero of smooth Z movement, the rod coupler. This little guy connects the lead screw to the stepper motor. It keeps those two connected nice and tight. Think of it like the coupling that connects train cars. If it's loose or broken, the whole train could derail.
So we need to make sure that rod coupler is snug, keeping everything together nice and tight.
Exactly. Check the grub screws that hold it in place and make sure they're nice and snug. If the coupler itself is messed up or worn out, then yeah, you might need a new one. But usually just tightening those screws is all it takes to get rid of the wobble.
Sweet. We've tackled all those mechanical things that could cause Z-wobble. Now what about those extrusion problems that can also lead to Z-banding? I'm ready to dive into the world of nozzles and filament.
Let's go. Remember our cake icing analogy. We need that filament to flow smoothly to get those nice, even layers. And just like a clogged icing tip can ruin a cake, a clogged nozzle can really mess up your prints.
So step one in our extrusion investigation is to give that nozzle a good checkup. How do we make sure it's sparkling clean and ready to go?
There are a few ways you can clean a nozzle. One is to use a tiny needle, like the kind you use for sewing, to clear out anything that's stuck inside. Just be super gentle and use a light touch so you don't scratch it.
So just a little poke with a needle can slodge those stubborn filament bits.
Got it. What other nozzle cleaning tricks do you have?
You can also try using cleaning filament. It's a special type of filament that's made to remove all the gunk and residue from the nozzle. You load it into your printer like you would with regular filament, and it's like a little pipe cleaner for your nozzle. Cleaning filament. I like that. Like one of those cleaning tablets you use for your coffee maker. Just pop it in and let it do its thing. What if our nozzle's just done for? Even a deep clean can't save it.
If it's toast, yeah, you'll have to replace it. But look-away nozzles are pretty cheap and easy to swap out. It's a good idea to keep a few spares on hand, just in case.
Nozzle. Check. Okay, let's talk filament. It's like the lifeblood of our 3D prints. You mentioned before that quality is important, but there's so many different kinds of filament out there. How do we pick the right one to make sure it's flowing nicely through the printer?
You're right. It can be a bit overwhelming trying to pick the right filament. But think about it this way. Using good quality filament is like using the best ingredients for your food. If you use cheap filament, it might have inconsistent diameter, have impurities, or be really brittle. All those things can cause extrusion problems and lead to banding.
Right. So it's worth spending a little extra to get that nice, smooth filament flow. What else should we be thinking about when we're choosing filament?
One important thing to remember is the filament diameter. Most 3D printers use either 1.75 millimeter or 3 millimeter filament, so you got to make sure you get the right size for your printer. Using the wrong size can cause a whole bunch of problems with the feeding and extrusion.
Okay, so always double check the diameter to make sure it's a perfect fit for our printer. Got it. What else?
It's also super important to store and handle your filament correctly. Filament can actually absorb moisture from the air, and that can cause popping and sputtering during printing, as well as that inconsistent extrusion that leads to Z-banding. So keep your filament in airtight containers with the thickent packs. That'll keep it nice and dry.
It's like protecting those old books from humidity. Got to keep the filament dry and in good condition. What about when you're actually loading the filament into the printer? Any tips for making sure it goes in smoothly and doesn't get tangled up?
For sure. Before you load the solvent, make sure it's feeding off the spool properly and that there aren't any kinks or tangles in it. Oh, and it's good to trim the end of the filament at a slight angle so it has a nice pointy tip. That makes it easier to feed to the extruder and the Bowden tube.
So no obstacles on that filament path. It's like we want a nice flowing river with nothing to clog it up. This is all great advice. Once the filament's loaded and we're ready to print, are there any settings or adjustments we can make to make the filament flow even better and prevent those bands?
Yeah, temperature is super important. Just like if you're melting chocolate, you need the perfect temperature to get it smooth and glossy. The same thing applies to filament. Too low, and it won't melt properly. Then you get under extrusion and gaps in your prints. Too high, and the filament can degrade and clog the nozzle.
So, like Goldilocks, not too hot, not too cold, but just right. How do we figure out the perfect temperature for the filament we're using?
Most manufacturers will give you a recommended temperature range, either on the packaging or online. That's a good starting point, but you might have to play around with it a little to find the sweet spot for your printer and the environment you're printing in.
So, kind of like baking, you might need to adjust the oven temperature a little depending on your oven and the recipe you're using. Mm-hmm. But it's not just about finding the right temperature, right? We've got to make sure it stays the same the whole time the print is running, too.
You got it. If the temperature goes up and down, the filament will melt and cool unevenly. Then you get those ridges and imperfections, like trying to bake a cake in an oven with the broken thermostat. Not going to turn out well.
So how can we make sure our printer is keeping that temperature nice and stable in a perfectly calibrated oven?
Well, first of all, make sure your printer's somewhere stable, not near a window or an air conditioner or anything that could change the temperature around it. We want to make sure it's comfortable and not getting blasted with heat or cold.
Okay, so no printing near open windows or space heaters. Makes sense. Are there any other environmental things to think about?
You could also think about enclosing your printer. There are enclosures you can get that help keep the temperature stable and give you a more controlled printing environment. It's like giving your printer its own little climate-controlled room.
Enclosures, that's a great tip. Like creating a tiny little greenhouse for your prints. Are there any other tricks we can use to get those temperatures under control?
Yep. Most 3D printers let you change what are called PID settings. Those settings control how the printer regulates the temperature of the nozzle and the print bed. If you tweak those settings a bit, it can help your printer keep a more accurate and steady temperature throughout the whole print.
PID settings sounds a bit technical, but I guess it's worth the effort if it means smoother and more consistent prints.
It can make a huge difference, especially if you're having trouble with those temperature fluctuations. Don't worry though, there are lots of tutorials online that can walk you through it step by step.
Perfect. We've covered a lot of ground here, from tightening those wobbly motors to cleaning those stubborn nozzles and taming those crazy temperatures. I'm starting to feel like a Z-banding superhero.
You're getting there. But remember, getting those super smooth prints we all want isn't just about fixing things when they break. It's about getting into good habits, doing regular maintenance, and basically taking good care of your printer. It's an investment, right? And in the end, you'll be a lot happier and have a lot more success with your prints.
Right, the power of prevention. That's like kicking your car for regular checkups. Saves you a lot of headaches and expensive repairs down the road. So, what are some things we should be doing regularly to keep our printers running smoothly?
The most important thing is just to inspect your printer often. Before every print, take a minute to check for any loose screws, worn out belts, or anything that looks like it's starting to wear out. Catching those little problems early can save you a lot of frustration later.
So a quick checkup before each print can go a long way. Just like giving your printer a little physical exam. Anything else we can do to pamper our printers and keep those parts moving smoothly?
Don't forget about lubrication. Just like a well-oiled machine, your 3D printer needs a little TLC too. Make sure to lubricate all the moving parts, like the lead screw, bearings, and anything else that slides or rotates.
It's like giving your printer a nice massage. Just a bit of oil can make all the difference. What kind of lubricant should we use? Can we just use any old oil from the garage?
Not exactly. 3D printers need special lubricants. You'll want to find something that's compatible with the materials and the temperatures that your printer uses. There are lots of 3D printer-specific lubricants you can find online or at hobby shops.
Okay, so we're checking for loose screws, lubricating all the moving parts, and just generally keeping an eye on how our printer is doing. What other preventative maintenance tips do you have?
Calibration is crucial. Think of that like a musical instrument. You need to tune it regularly to make sure it sounds good. Well, your printer needs to be calibrated to make sure all the movements are accurate and precise.
So basically, we're making sure everything is in sync and moving exactly the way it should, which will give us those perfect prints. What does calibration actually involve?
There are different types of calibration. One is called calibrating the extruder steps that basically make sure the printer is putting out the right amount of filament. And then there's calibrating the axis steps, which make sure the printer is moving the right distance in the X, Y, and Z directions.
So fine-tuning all the movements, making sure everything is lined up and moving with perfect accuracy. Sounds good to me. Any other calibration tips?
We talked earlier about adjusting those PID settings for a consistent temperature, and you might need to do some more advanced calibration depending on your printer and the types of prints you're making, like leveling the bed to make sure the printing surface is totally flat, or calibrating the flow rate to adjust how much filament is being extruded.
Sounds like calibration is super important if we want to keep our printers happy and healthy. And it's not just a one-time thing, is it? We should be doing this regularly.
You got it. Think of it like going to the doctor for a checkup. It's better to catch problems early, right? Same thing with your 3D printer. Regular calibration can prevent bigger problems and keep your prints looking great.
Calibration, check end. As this has all been super helpful, anything else we should be thinking about to prevent Z-banding and wobble and get those prints super smooth?
We've covered a lot, but I do have one last tip. Choose your filament carefully. We've already talked about quality, but it's not just about finding a good brand or material. Some filaments are just naturally more prone to certain issues that can cause Z-bending. So it's about finding the right filament for the job.
So it's not just finding good filament, it's like using the right tool for the job. What kind of things should we consider when choosing filament for a specific project?
Think about how flexible the filament is. Some filaments, like PLA, are pretty rigid. Others, like KPU, are super flexible. If you're printing something that needs to bend with a phone case, then using a rigid filament isn't going to work well. The filament's flexibility can affect how well it flows and sticks to the layer below it, which can lead to Z-banding.
Right, so we're thinking about the properties of the material and how it will act during printing. What other things about the filament should we be looking at?
Pay attention to the filament's shrinkage rate. Some filaments shrink more than others when they cool down after being extruded, and the shrinking can cause stress in the print, and that can lead to warping, cracking, or even Z-banding. So if you're printing something big and flat or something that needs to be a very specific size, choosing a filament that doesn't shrink as much can help with that.
So we're thinking about how the filament acts during printing and also as it cools down. Like when you're baking a cake, you want to make sure it doesn't sink or crack when you take it out of the oven.
Exactly. And remember, experimenting is key. What works on one printer might not work on another. So don't be afraid to try different filaments, adjust your settings, and see what works best for you and your printer.
This has been amazing. I feel so much more prepared to tackle those Z-banding and wobble challenges. But before we wrap up, I want to make sure we've all got the key takeaways. We've talked about a lot, so let's go over everything we've learned so far.
Sounds good. A little recap is always helpful. So we learned that Z-banding is that annoying pattern of lines we sometimes see in our prints, and it's caused by either mechanical problems with the Z-axis or by the filament not flowing consistently. We learned about those main components of the Z-axis, the stepper motor, lead screw, and rod coupler, and how to troubleshoot and fix any issues.
Right. And we also got into the nitty-gritty of filament, learning about choosing good quality filament, keeping it dry, and making sure it has a clear path to the nozzle. Plus, we learned all about temperature control, making sure we're using the right temperature, and that it stays consistent the whole time we're printing.
Preventative maintenance is. Those regular checkups, lubrication, and calibration can help keep your printer in great shape and prevent those annoying banding problems in the first place. And we emphasize how crucial it is to choose the right filament for what you're printing, taking things like flexibility and shrinkage into account.
Wow, we covered a lot. I'm so glad we went through all of that. But before we sign off, I'd love to hear your final thoughts on Z-banding and Z-wobble. What's the most important thing you want everyone to remember?
I think the biggest takeaway is that getting those perfect, smooth prints isn't just about fixing things when they go wrong. It's about building those good habits, taking care of your printer, and doing those regular maintenance checks. It's an investment, and in the long run, it will make you a happier 3D printing enthusiast.
Couldn't have said it better myself. Now, let's answer a few questions from our listeners. They've been sending in their Z-banding and Z-wobble woes, and I know we can offer some guidance. Are you ready to put on your troubleshooting hat again and help our fellow makers conquer those pesky
lines? Bring on the
lines?
questions. I'm always happy to share what I know and help people reach their 3D printing goals.
Awesome. Let's dive into the mailbag and see what kind of problems our listeners are having. All right, our first question comes from Sarah, who says, I'm getting Z-banding, but only when I print tall cylindrical objects. Everything else prints just fine. What could be causing this?
Sarah. It sounds like maybe there's a slight bend in her lead screw that gets more noticeable as the print gets taller. So it's like a little wobble in a bicycle wheel.
You don't really notice it when you're going slow, but once you speed out, the wobble gets really obvious.
If there's even a tiny bend, it can add up and make the banding worse on those taller prints.
What would you recommend in this case?
I'd say check your lead screw for bends using that rolling technique we talked about before. If you do find a bend, you might want to just get a new one. Also, pay attention to how you've got your filament spool mounted. Sometimes, if the spool isn't feeding smoothly, it can put tension on the filament, especially on those longer prints. So make sure the spool is turning easily and that there's no resistance when the filament comes off.
Great advice. Okay, next up is James. He says, I've tried everything to fix my Z-banding new nozzle, calibrated everything, high quality filament, but I still have those lines.
James has done all the right things. So in this case, it could be something less obvious, like maybe the temperature is fluctuating in the room, or there are vibrations from something nearby.
Right, like trying to bake a cake while the washing machine's on spin cycle.
Exactly.
Cake's not going to turn out very
smooth.
James,
I'd say try printing in a different spot, maybe one that's a bit more stable. You could try enclosing your printer or moving it away from anything that might be causing vibrations of drafts.
Good point. Sometimes it's those little environmental things that can make all the difference. Okay, last question for today is from Maria. She says, my Z-banding is worse on one side of my prints than the other.
That's interesting.
Any ideas?
It could be that her Z-axis isn't aligned properly, or maybe there's a bit of play in one of the linear rails. It's possible that one side of the Z-axis is moving a little more than the other, which would explain why the banding is worse in that area.
So it's kind of like when your car pulls to one side while you're driving, something's out of whack and needs adjusting.
Maria, I would suggest checking the alignment of all the parts in your Z-axis, especially the lead screw and the linear rails. Make sure everything is nice and square, level, and tight. Great
tips, Kenneth. It sounds like our listeners are well equipped to get rid of that Z-banding and get those beautiful, smooth prints they've been dreaming of.
Just remember, everyone, a little bit of knowledge and some preventative measures can really go a long way. And don't be afraid to experiment and try different things. Every printer is different, and what works for one person might not work for another. So it's all about learning, adapting, and figuring out what works best for you.
That's a great way to put it. Okay, Kenneth, we set out a few more listener questions in the mailbag. This question is from Bob, and he says, my prints have these weird horizontal lines that seem to be getting worse over time. At first, they were barely noticeable, but now they're pretty bad. Could this be Z-banding, or is this something else?
That does sound like Z-banding, Bob. And the fact that it's getting worse over time makes me think it might be some wear and tear in your printer's mechanics.
So it's kind of like those squeaky hinges on an old door. At first, it's just a little creak, but if you ignore it long enough, it turns into a full-on groan.
Yep. That's a great way to think about it. With Z-banding, it's often those little mechanical issues that can gradually get worse if they're not addressed. But I would suggest taking a close look at those key components we talked about earlier, the stepper motor, lead screw, and a rod coupler.
Right, our Z-axis dream team. What exactly should Bob be looking for?
First, make sure that stepper motor is still securely mounted. Even if it's just come loose a little bit over time, that can cause vibrations and wobbles. Then take a look at the lead screw and see if there's any wear and tear. Does it turn smoothly, or do you feel any bumps or resistance when you rotate it?
So, basically checking for any signs of damage or aging, maybe a little rust or a slight bend. What about the rod coupler? What should we be looking at there?
Check that the rod coupler is nice and tight and that there's no wiggle room between the motor shaft and the lead screw. That connection needs to be solid to prevent any wobbling.
Got it. So Bob's mission is to give his Z-axis a thorough inspection and look for any signs of wear and tear or loosening. What if he doesn't find anything obvious, though? Are there any other sneaky culprits that could be causing those progressively worse lines?
There are. Sometimes the problem is with the bearings that help the Z-axis move smoothly. Over time, those bearings can wear down and create a bit of play, which can lead to those lines. If Bod has checked the stepper motor, lead screw, and rod coupler, and everything seems fine, I would suggest taking a look at the bearings. If they're worn out, it might be time to replace them.
Right. It's like figuring out that the problem with that squeaky door isn't the hinges, but the bearings inside them. Sometimes you have to do a bit more digging to find the root of the problem. Okay, our next question comes from Susan. She says, I'm getting really bad Z-banding on a large flat print. It's almost like the entire print bed is tilted or warped. What could be causing this?
It sounds like Susan might be dealing with an uneven print bed surface. If the bed is warped or tilted, the nozzle will be closer to the bed on one side than the other, which can create those uneven layers and really noticeable Z-banding.
It's like trying to build a house on a foundation that isn't level. The whole thing is going to be wonky.
Exactly. If you're doing big, flat prints, a perfectly level bed is super important. Susan, there are a couple of things you can try. First, check that your printer has a good bed leveling system. Lots of printers these days have automatic bed leveling, which can adjust for any little variations in the surface. If your printer doesn't have that, you can level the bed manually with a fewer gauge or a piece of paper. That way you can make sure the nozzle is the same distance from the bed all the way across.
So it's like adjusting the legs on a table to make sure the tabletop is perfectly flat. What if Susan has already checked the bed level and everything seems to be okay? Are there any other things that could be causing this?
Definitely. Even if the bed itself is level, the problem could be with the printer's frame. If the frame isn't totally square and rigid, it can twist or warp a bit, which messes up the bed level and causes those uneven lines. This is especially true with large prints.
So it's like building a house on a foundation that's shifting around. Even if you get the floor level, those movements in the foundation are going to mess everything up. What can Susan do if she thinks the frame is the problem?
Well, she can start by checking all the connections and bolts that hold the frame together, make sure everything is nice and tight and that there's no wobble in the frame. If anything is loose, tightening those connections up might be all it takes to fix it.
Okay, so we're making sure that foundation is solid and secure. What if Susan has checked all the connections and they seem tight, but she's still getting those Z-bands, especially on bigger prints?
In that case, she might need to reinforce the frame itself. There are a few ways to do this, like adding some diagonal braces or using stronger, thicker material for the frame parts.
So it's like adding extra support beams to a structure to make it stronger and keep it from bending. Makes sense. Okay, let's get to our last listener question for today. This one is from Mike, and he says, I'm seeing Z-banding in my prints, but only in certain spots, like around curves or corners. The rest of the print looks fine. What's up with that?
That's a sharp observation, Mike. Z-banding that only shows up in certain areas often means there's an issue with how the printer is moving, specifically the belts and pulleys that control the X and Y axes.
So it's not just about the Z-axis moving up and down smoothly. We also need to make sure those side-to-side and front-to-back movements are perfect, especially when the printer is going around curves or corners.
Right. Think about driving a car. If your steering wheel is loose or your tires are out of alignment, it can be really hard to make smooth turns.
So the belts and pulleys are like the steering and suspension for our 3D printer. They need to be in good shape to make those precise movements. What should Mike be looking at when he's checking his belts and pulleys?
First of all, check how tight the belts are. If they're too loose, they can slip or stretch, which will cause the printer to move inaccurately and get those bands in certain areas. If the belts feel loose, you can tighten them up using the tensioners.
So we're making sure those belts are nice and taut, just like the strings on a well-tuned guitar. What else should Mike be checking?
Take a look at the pulleys too. See if they're worn out or damaged. Over time, the teeth on the pulleys can get worn down, which makes it harder for the belt to grip properly. If the pulleys look worn, you might want to replace them.
Right, those pulleys need nice sharp teeth to grab onto the belt and keep things moving smoothly.
Yeah.
What if Mike has checked the belt tension and the pulleys and everything looks good, but he's still getting Z-banding in those same spots? What else could be going on?
It could be that the belts and pulleys aren't aligned properly. If they're not perfectly straight, it can cause tension or binding, which can affect how the printer moves and cause those localized banding issues.
So it's not just about the parts themselves. It's about making sure they're all working together in the right way. Exactly.
Mike, there are specific alignment procedures for most 3D printers that you can follow to make sure your belts and pulleys are in the right spot.
Great. Well, Kenneth, it's been an awesome journey into the world of Z-banding and Z-wobble. We've learned about the mechanics of the Z-axis, the ins and outs of filament, and even how to keep our printers in top shape to prevent these problems in the first place. I think our listeners are well equipped to tackle those annoying lines and get those perfect prints they've been dreaming of.
I agree. I think the most important thing is to be observant, try things out, and don't be afraid to experiment. Every 3D printer is different, so what works for one person might not work for another. It's all about learning as you go and finding what works best for you and your printer.
Couldn't have said it better myself. And remember, there are tons of helpful people in the 3D printing community who are happy to share what they know. So don't be shy about asking for advice in online forums, Facebook groups, or your local makerspace.
Exactly. The more we share and learn from each other, the better we all become as makers.
That's the perfect note to end on. Thanks for joining us for this deep dive into the world of Z-banding and Z-wobble. We'll be back next week with more 3D printing tips and tricks. Until then, happy printing, everyone.